Hello students, welcome back to my channel and I hope you are doing fine, and today in this video we are going to discuss about chemical kinetics. Today our topic of discussion is chemical kinetics. Chemical kinetics. So to have a better understanding about the word chemical kinetics, let us decode the word itself so that we will have better understanding about it. So the word chemical refers to the chemical reaction. Chemical reaction. And kinetics is nothing but the movement. Kinetics meaning movement. Movement of what? Movement of reactants into the products. That is, how faster the reactants are converting into the products or how slower the reactants are converting into the products. That means you can say speed of a chemical reaction. In terms of chemistry, the same thing you can call it as rate of a chemical reaction. So we are going to study about rate of a chemical reaction. So in this chapter we are going to study rate of a chemical reaction, and second one, factors controlling the rate of the reaction, which means like whether the temperature, pressure, these kind of factors, what is the impact on the rate of a chemical reaction. So factors controlling the rate of the reaction we are going to study. And finally, third one is mechanistic aspects, mechanism of the reaction. These are the three things that we are going to study in this chapter. So before entering into the topic directly, let us have a small discussion about complete understanding of a chemical reaction. That means, let me take an example of a chemical reaction. A plus B is giving C. I have taken a reaction A plus B is giving to C. For the complete understanding of this chemical reaction, we should be knowing about three important aspects. That is, one is feasibility. Feasibility. Second one is extent of the reaction. First one is feasibility of the reaction, and second one is extent of the reaction takes place, and finally third one is rate of the reaction. So here feasibility is nothing but whether the reaction feasible or not, whether the reaction takes place or not. That means you can get this information from thermodynamics. In thermodynamics, whether the reaction is spontaneous or not, takes place or not, we will discuss it through delta G. And extent of the reaction, if you want to know whether how much the reaction going to takes place, how extent the reaction is going to take place, that means like whether the reaction is going to take place 50% or 100% reaction takes place. This kind of information you are going to get from the equilibrium. And finally, rate of the chemical reaction, which you can get it from the chemical kinetics. That is what the topic of discussion today. So for the complete understanding of a chemical reaction, we need to understand all these three things. We have already discussed about feasibility in thermodynamics, and second one, extent of the reaction, we have discussed in equilibrium. And today our topic of discussion is rate of a chemical reaction. We are going to discuss in chemical kinetics chapter. So this is all about the introduction topic, the introduction about the chemical kinetics. So in the chapter chemical kinetics, we are going to study rate of a chemical reaction, and second one is factors controlling the rate of the reaction like temperature, pressure, and third one, mechanistic aspects of a chemical reaction. We had a small introduction about the chemical kinetics. So now we are going to discuss about rate of a chemical reaction. What is rate? Rate is nothing but the change in concentration of the reactant or the change in concentration of the product with respect to time. Rate is nothing but change in concentration of reactant or product with respect to time. Change in concentration of the reactant or product with respect to time. Mathematically, you can write change in concentration by change in time, dx by dt. So Let me take an example of A plus B is going to give C. This is a chemical reaction. Here A and B are the reactants and C is the product. As time goes, means at time t is equal to 0 and time t is equal to 10 seconds, 20 seconds, 30 seconds. As time goes from 0 seconds to some n seconds, concentration of A and B are going to decreases. Because A and B are the reactants and they combine to give C. So obviously the concentration of A and B in the reaction as time goes decreases. And C is the product. As time goes, the concentration of C increases. That means you can say there is definitely change in the concentration of A, B and C. That means the change in concentration of reactant as well as the products along with the time, which is nothing but the rate of the reaction. So if you want to write the rate for this particular reaction, I will write change in concentration of A with respect to change in time, which is equal to change in concentration of B with respect to time, change in concentration of C with respect to time. So if you want to talk about the rate of this particular reaction, you can talk in terms of A, in terms of B, in terms of C. Whatever may be the reactant or product, you can talk about the rate of the reaction of rate of this particular reaction. But one thing I would like to tell you, as we have discussed, the concentration of A and B decreases with time and concentration of C increases with time. So to show the difference whether the reactants and products increases or decreases with respect to time, to show that difference, I would like to keep minus over here, which tells the concentration of A is going to decrease in the reaction and concentration of B is going to decrease in this reaction and C is going to increase in this reaction. This negative sign doesn't have any mathematical value. Its significance tells that concentration decreases with respect to time. But there is no mathematical sign, mathematical value for this sign. So if I want to write for a rate of this reaction, I will write like minus dA by dt is equal to minus dB by dt is equal to minus dC by dt. Let me take another example. This is example number 1 and example number 2 I will take A plus 3B going to give 4C. This is a chemical reaction that I have written. So I want to write rate for this reaction again. So minus change in concentration of dt, as A is going to decrease, I kept minus over here, and again minus dB by dt with respect to C, plus dC by dt with respect to time over here. So one thing I would like to, you have to notice over here all the reactants and substrates have the stoichiometric quotient is only 1 over here. But here in this equation, here it is 1, here it is 3 moles, here it is 4 moles are going to get. Here 1 mole of A and 1 mole of B going to give 1 mole of C, and 1 mole of A here, 1 mole of 3 moles of B, 3 moles of B combined to give 4 moles of C. So maybe the reactants are same but the stoichiometry is different over here. So here in writing rate of the reaction, we need to show the difference over here. That means one important thing that you all need to know is rate we always write in terms of 1 mole. Rate we always write per mole. So here only 1 mole of the reactant, so no need to keep anything over here. But here it is 3 moles. But for rate we need to write per mole. So we have to write 1 by 3. Here it is 4 moles, but for rate we need to use only 1 mole, 1 by 4. That means out of 3 moles we are talking about only 1 mole. Here out of 4 moles we are going to talk about only 1 mole. So however may be the moles of how many moles that has given in the question, you need to talk about the 1 mole to talk about the rate of the reaction. So for the rate of the reaction, this particular reaction, if I want to write the rate, so I have written minus dA by dt, which is equal to minus 1 by 3. That means out of 3 moles I am talking about only 1 mole because I am talking about the rate of this particular reaction. Here which is equal to 1 by 4 dC by dt means out of 4 moles I am talking about only 1 mole. So this is the concept that you should all aware of. So whatever may be the chemical reaction, whatever may be the stoichiometric quotient, you need to keep that stoichiometric quotient in the denominator so that in writing rate of a reaction, you will be successful. Let me take another example to get more clarity in writing rate of a chemical reaction. I'll take our favorite example, N2 plus 3H2 gives 2NH3. We know ammonia formation. Let us try to write rate for this particular reaction. That is change in concentration of nitrogen with respect to time. Since it is a reactant, I have kept minus over here. And next, change in concentration of hydrogen with respect to time. But here I have stoichiometric quotient 3, so I need to keep it over here in the denominator, because out of 3 moles in writing rate of a reaction, I need to use only 1 mole. So I have written change in concentration of hydrogen with respect to time. And now it is the product, so no need to keep minus over here, but here it is 2 moles. Again I need to keep this 2 in the denominator. So change in concentration of ammonia with respect to time. So this is how we need to write the rate for any particular reaction. You need to keep this stoichiometric quotient in the denominator, and if it is the reactant, you need to keep minus over here to show that the reactant concentration decreases with respect to time. And if it is the product, you need to keep plus over here, means no sign means plus over here. That means the concentration with respect to time increases. And second thing, the stoichiometric quotients need to be in the denominator. This is how we need to write the rate for any particular kind of reaction.